Welcome to Thursday of week 7 with Level C Math. We're still going through justice. Last time we finished up with proportions and proportion word problems, but we only talked briefly about scale factors. And we have a homework question to do about at least one of the homework problems. Then we talked about percentages on last time, and we did the percent sentences, but we only introduced the word problems a tiny bit. So the thing that makes sense today is to go over homework questions that we have, but go through scale factors with a bit more detail and do lots of example problems from the percent sentences. So that's our agenda for today. There won't be new homework. In theory, if you practiced a lot, you could do the 10 exercises for the fractions and the percents already. But realistically, having seen all of the example problems will help a lot for that today. I am pretty sure we won't get to measurement today. I would be very surprised. So we'll wind up being done with these two. And next week, we can start measurement. Okay, I will get rid of that. And let's talk about scale factors. I'll go ahead and put these on the Jamboard again. So in general, scale factors aren't amazingly useful because when you're doing just one problem, the numbers are usually not this friendly. In the example on the board now, you can just look at it and say, oh, this is unreducing the fraction. 40 and 1 become 80 and 2 with a times 2. So if the problem had been 40 miles over 1 hour is how many miles over 2 hours, then you can say this is just a times 2. So this one will also be a times 2 and get your 80. Similarly, on the bottom, if the problem was how many cents for a 15 minutes of parking meter is the same as 75 cents for a 45 minutes of parking meter, then you could have looked at this way and said, oh, we're doing a divided by 3. We're reducing that fraction. So we need to do a divide by 3 here and get 25 cents. But seldom will the numbers work out nicely. Too often in real life, we have decimals or things that aren't just times 2 or times 3 or some other friendly whole number. So the time that scale factors actually become useful is if you're doing a similar problem several times. So let's look at this one. Open it in a different window so it's not too wide. Okay. So in this example problem, we have an elementary school student and she's doing a project out at the playground. So she is 4 feet tall. And her shadow is 12 feet tall. So she's wondering, how long would the shadows be for the 3 other students that are 4 foot 2 inches, 4 feet 4 inches, and 4 feet 6 inches. So this makes sense as a scale factor because we're doing the same kind of thing 3 different times. And that repetition will make this more efficient. Is everyone with me just with the situation so far?
Yeah.
If we do this the old-fashioned way with a proportion, we could say that a 4-foot student has a 12-foot shadow. And now we know that student has to be on top to make it match. And shadow has to be on the bottom. I'm going to run into some trouble. 4 foot 2 inches doesn't quite match. What can I do so that my quantities on the top work better? Because I don't really want to write 4 foot 2 inches right there. That's awkward to deal with.
Change it to inches.
Yeah, let's make everything inches. So this one is 48 inches, 4 times 12. This one is the same, 2 more. So this is 50 inches. That's 48 plus 4, 52 inches. This one is yet 2 more inches, 54 inches. So now we can write 48 inches is a 12-foot shadow, 50 inches is how big a shadow. We could cross multiply and solve that. Everyone with me so far?
Yeah.
Yeah.
I'd have to do that problem 3 times for the 50 inches, and I'd do it again for the 52 inches. I'd have to do it again for the 54 inches, and I would get sick of this. If I think about it with scale factors, then in that case, this is easier. How do I get from 4 feet to 12 feet?
You divide.
If I was going the other way, I would divide
Multiply.
Times by 3.
times 3, right? So I can just take all of these and do a times 3. I'm noticing that however tall the student is, the shadow is 3 times as long. So this one is 150 inches. This one's going to be 156 inches. And this one is going to be 162 inches. I could be done. Maybe somebody wants me to write it as a mix of feet and inches. But that was a lot faster to just do a times 3 each time than to try and do the proportion each time. Should we be done with this one, or do you want to take these numbers and change them into so many feet and so many inches?
Can we turn it to feet, please?
Sure. So we had the 12 feet here. And if we multiply that by a 12, we get 144 inches. Right? So this one would be the 144, that's the 12 feet. And then how many are extra to get to 150?
6.
6. For the second classmate, then if I'm going from 144 to 156, that's going to be a jump of 6 here. And a jump of another 6 here. So 6 and 6 is 12, 12 more inches, that's going to be a whole nother foot. So now I'm at 13 feet. And this is a jump of another 6 inches. So that's just going to be 13 feet, 6 more inches. There might be somebody else that says, you know, I don't like either of those. I would rather write at 12.5 feet. Or 13.5 feet. I like decimals, and that's okay too. Whoever asked this problem didn't really care which of these ways we wrote it. Is everyone clear why you have a 6 inches that becomes a 0.5 and not a 0.6?
Yeah.
Okay, let's do another one that has this kind of repetition to it. 59. No, let's do 60. 60 sounds more fun. So I'm looking at some hiking trails while planning some kind of family hike or trip or something. And 1/2 inch is going to be 3 miles. So how do I get from inches on the map to real life miles? What am I multiplying by as my scale factor?
Would it be times 6?
It is. How did you get that?
I just figured that half of 6 is 3. So
Yeah, if you do 6 divided by the, I'm sorry, not 6. If you do 3 divided by that 0.5, you get 6. You could think of it as a half and a half makes 1 mile, and another half and another half makes 2 miles, and another half and another half makes 3 miles. So there's 6 or something like that. In any case, we have 3 trails that my family might want to hike on. I have 1.5 inches, 1.75 inches, and 2.1 inches. And they could set up lots of proportions, right? The first one we could do 0.5 inches is 3 miles. That's one situation. And then so 1.5 inches is how many miles, and do our cross multiplying. So we could do 3 different proportions where this side changes for each of the other numbers. But that's a lot of work. It's easier to just say whatever we're doing times 6 and getting how many miles it is. So this one will become 9 miles, 1.75 times 6, 10.5 miles, and 2.1, 2 6s is 12, so that's going to be 12.6 miles. Okay, questions about this slide?
no.
Questions about scale factors in general?
I think I'm just gonna have to look over the notes from last class because I wasn't there, so I'm a little behind.
Okay, we will soon do a lot of review of the last class.
Okay.
Okay, so that was the scale factors thing, which again, you don't have to pay attention to. You can always solve these just by doing lots of cross multiplying proportions. This is just sometimes more efficient. Okay, somebody wanted to do number 10. Go back and get it from this window so it's wrapped around better. So this is about the trickiest we can ever get with our proportions. And I warned you last time, please try this at home. I'm glad some of you did. And what we can't do is just make all of our labels deer. because then we don't get the feedback about if we put in the numbers in the right place. If everything is deer, I don't know if these match or not. So let me get rid of that. And for Brandy, who wasn't here last time, then what we did was look in the beginning of the video for last class, and we had 4 different ways that we were trying to put a word problem into a proportion. And some of them worked and some of them didn't. And what we found out was that what most people find happiest is if one side where 40 miles over 1 hour is circled, one side is one situation and the other side is the other situation. And the words are symmetrical. If miles is on top, it stays on top. If hours is on the bottom, it stays on the bottom. And when that doesn't work, then the math won't work out well. You'll get something like here where 40 times 80 is different than 1 times 2 or something like that, because the hours and miles aren't matching. So we want different words where this word is the same as that one, and this word is the same as that one, and we can keep ourselves organized. Okay, so what is a situation that we should have on this side? And what's a situation we should have on this side?
I don't know if I did it right, but I did 168 deer over 56 tagged.
So you did 168. And that is, let me read it again for people that haven't caught up to you and started it yet. So there's a deer in a game preserve. We're not sure how many. So the forest ranger catches, tags, and releases 318 deer. So of all of them, we don't know how many, 318 are now running around with tags on them. Then he catches later on 168 of those and sees that 56 of the second catch were tagged. So 168 is the second catch total. Make that a little nicer. And 56 is the second catch tagged. Is everyone okay with how I labeled those?
Yeah.
Yeah.
Okay. So I want that this situation, number 1 is the second catch. If my situation on the other side was the first catch, that wouldn't work well. I'd have 318 in both spots. Does that make sense? That's the total and tagged for the first catch. So that's not right. What's my second situation if it's not the first catch?
Is it releases? Would it be?
I'm not sure.
The ones he releases are in this case, the same as the first catch. He caught and released all those once he put tags on them. What are we looking for? We need the number we're looking for on our proportion somewhere.
The number of deer.
The number of deer where?
In total.
In total, the entire game preserve, right? So that we can do, that we have a entire preserve total and the entire preserves tagged. And we know that inside the entire game preserve, we're not sure how many are there total, but there's 318 that have tags on them. So look at the symmetry. We have this situation is the second catch. This situation on the other side is what's in the entire preserve. And on both situations, total is on top and tagged is on the bottom. Does that make sense?
Yeah.
So yes, Sequoia had set it up right. If you just put deer everywhere, then maybe you flip these numbers and put the 56 on top or something and you don't know it. But yes, this is the 4 ways to set up, or the right way to set up the 4 things. Okay, now we know how to do these. We're going to multiply the diagonal that has the y, because that always looks nicest on the left-hand side. And we'll multiply the diagonal that doesn't have the letter. If you weren't here last time, let me know if I'm going too fast. So what is 168 times 318? 35,424. Now we have y times something equals something else. How do we get y by itself?
Divide by 56.
Divide by 56. And 954 is our answer. We also talked last time that you don't really need the black line here in the middle. If you like writing it a different way, let me see if I can be clever and do this. No, it doesn't cover it up. Okay, never mind. Then you can leave out the black line and just say that we're going to have this times that divided by that. And the fact that it was 35,424 doesn't really matter. You would just do on your calculator the 168 times the 318 divided by the 56, all in one set of 3 things. We'll write more like that. Okay, other homework questions with the 10 problems for proportions.
I'm good.
What else wants more? Let me set up number 2, just in case somebody is watching this at home. This one is not a hard one, it's just worded awkwardly. It's saying, is the proportion, or solve the proportion 7 to 1/4 is 28 to what? So wherever you see the word two, that becomes a fraction bar. And then you would do the same thing, multiply, solve for y. Let me, no, I don't want to do this one for you, but
Could you also make the 1/4 0.25?
yes, if you like decimals better, you could certainly write that 0.25. So, okay, well, let's go on. So we talked about percent sentences and actually, and how they are like kind of Mad Libs problems. And we could always write things with the thing that kind of looks like this. Blank is blank percent of blank. So we're going to use that and translate from it. I'm going to make it a little smaller. So one of the things we did was the translate method. We also had the proportion method. And if you were using the proportion method, then you could actually write it out like we do here, like Mad Libs, blank is blank percent of blank. But it was also okay to just jump right to drawing it as a proportion. The thing that would be your percent number always goes in this corner. Then when you have the blanks, this one is always going to be your part or your change or your new amount. And this one is going to be your whole or your original or your baseline, whatever you're comparing things to. So the one that's often the part goes on top on that side, and the one that's often the whole goes on the bottom on the other side. What that means is that this one is part over whole, but it's as a percent. 100 is the whole of percent, and then whatever the percent number is the part as a percent. So it's just part over whole on both sides, once written as a percent and once not. So if you weren't here, that was me talking a lot, and it's confusing because you don't see any actual example, but we'll get there. If you were here last time, then hopefully that was a good quick review. But I'm not going to ask for questions because we really just need to do one. So let me grab this one. And let me grab this stuff to put on the next slide before I write on it. Okay, so somebody's car. Did we do this one? We did this one last time, didn't we?
Yeah.
Yeah, let's do a different one. Okay, goodbye, William. Let's try this one. During the school year, Eugene has a population, oops, why does that say 65? It shouldn't say 65. Of 180,700. The University of Oregon has 20,600 undergrad students. What percentage of the school year population are those undergrad students? So if you are doing it the translation method, you'll have something is something percent of something else. We have two numbers, and then we'll always have something that's the what. We're not sure what it is. So which of the things go in which of these three spots for this particular problem?
$20,600 goes in the first spot,
Yes, that's the part. That's this.
and the whole is 180,700.
That's the whole. And then, so this must be what? So our question we're asking, the way we could paraphrase this larger paragraph is 20,600 is what percent of 180,700? You could even put a question mark if you wanted. Everyone okay with filling in the blanks?
Yeah.
And if you can do that, then you can do any of these word problems because they are all like that. Okay, so as we keep going, we're going to translate things. Numbers just stay numbers. Is becomes equals. What becomes our letter? Of becomes multiply. Numbers stay, oops, numbers. I have something stuck onto y with multiply. How do I get y by itself?
You divide.
Divide by whatever is stuck on y. And if I do it to one side, then again, our theme is justice. We have to be fair. We have to do it to the other side also. So 20,600 divided by whatever that was, 180,700. Whoops, my calculator forgot when I tabbed over where I was. There we go. So it's about 0.11. I'm going to make this a little taller in case it's too close to the bottom of your screen. I'm not quite done. 0.11 is a good answer, but what do I have to do?
Riplop.
Yeah, it asked for a percent, so I need to give it a percent. So write into percent. And we get 11%. Everyone okay with the translate method, if that's what you like?
Yeah.
The other method was the proportion method. So we make our different skeleton now. Instead of this kind of Mad Libs thing, blank is blank percent of blank. Now we just have fraction bar equals fraction bar. On this side, we want part over whole with the percent numbers. So the part is what percent? That's the thing we don't know. And the whole for a percent is 100%. We don't need riplop because that's just sort of like a label that's here, but we're imagining it. So you will see we don't need riplop. On the other side, we need part over whole as numbers. So you would do the same thing. You would look at the paragraph, you'd say the part is the 2,600 and the whole is the 180,700. Oops. For exactly the same reasons we said that that was the part and that was the whole last time. Then we cross multiply. I have something stuck onto y with multiply, so I'll have to divide by it. I'm skipping the line that I said you could skip, written in black, where you multiply these two numbers and get a single thing. That helps us recognize it's a one-step equation. Y times something equals something. But it's okay if we don't condense that into one number. It's still true that this really is one number, even if we haven't condensed it yet. And now we will get y is about 11. It will not be 0.11, it's just going to be 11, and we just put a percent sign on it. Because again, the over 100 is how we pay for that percent sign. These things have sort of hidden percent signs on them already. Okay, questions on the right-hand side if you're a proportion method kind of person.
I'm good.
I'm good.
And let's do another one. So similar problem, I'm trying to trick you. Shrink that one just a little bit so I can draw my line down the middle. U of O has 20,600 undergraduates. We just saw that. It has 3,800 graduate students. What percentage of the U of O students are undergrad? Well, actually, I'm going to move this up more, which means I should erase that a little bit. Do you see where I am tricking you as I wrote this problem?
Yeah.
Sometimes it helps before you jump in to just label things. So our part, which one is our part?
3,800.
No, it doesn't ask what the graduate students are.
20,600.
Yeah, this one here is our part. That's the part it asks about. It could have asked us for graduate students, but it didn't. What's the total?
Is it the same as the 20,600?
No, then you're making all these grad students feel neglected.
The undergraduates and the graduates added together.
Yes. So it doesn't tell us the total is one number on the page. We'd have to say, what is the 20,600 plus, oops, plus the 3,800 and get 24,400. Okay, now we're ready to plug things in. So the part we said is the 20,600. That goes in the part spot as a number. The whole is the 24,400. That goes in the whole spot as a number, whichever way you like writing it. The whole as a percent is always 100 here. And then what do we put in the last spots?
Why?
Yeah, y or what. We'll make a y right away. So if you're a translate person, you have that. If you're a cross multiply person, you have that. Try and finish it on your own, whichever side you like best. And then tell me what you get.
I'm done. I used the proportion side. I got about 84%.
Okay. So we'd want y by itself. And so 100 times the 20,600, and then divided by the 24,400. And yes, it's about 84%. You are fast and accurate. If you're on the other side, you would also have divided by 24,400. You would first get roughly 0.84. And then you would use Riplop to make that 84%. Going right into percent. Okay, everyone happy with whichever way you did it?
Yeah.
Are you ready for one that you do all by yourself?
Yes.
Yes. Okay. So one serving of chocolate frosted sugar bomb cereal has 7 grams of fiber. That happens to be 29% of your recommended daily amount of fiber. So what's the total recommended daily amount of fiber? I'm going to pause the recording. If you're watching this at home, try and do this yourself, and then we'll talk about it together in a moment. Hopefully you've worked this out. Which side do you want me to start first?
I think the proportion side because it's faster. So people that are still translating may still be doing it.
Okay. So we draw that. This one's always 100. We might as well just fill it in. What's the part as a percent? That's usually easy if they give it to us.
29.
29. And then which of the others are part and whole?
7 is part.
And the whole we don't know. I'm going to do one more thing. I'm going to highlight on my problem grams. Since it's a word problem, I need to label my answer. So as I'm setting things up, I'm going to remember I want to put my answer in grams. If you wanted, you could also label things here. Oops, that this side is your percents, and this side is your grams. But you don't have to. Some people think that putting more things here just sort of clutters it up. Anyway. y times 29. Does anybody want me to write the line that has 700 on that side, or are we skipping that always?
We can skip it.
So 7 times 100 divided by 29. I get about 24. Whoops, not 24%. I'm forgetting my own advice. It's 24 grams. On the other side, you would do something is something percent of something. Our part would be 7 grams is 29% of what grams? Translate everything. In the previous problem, we had to find the percent. So that involved a riplop at the end to put something in percent, because that's what we wanted. In this case, we have a percent. So we're going to use riplop right away to make it something that's calculator friendly. Now, instead of going right into percent, we're going left out of percent. Questions about either of those?
I'm good.
This one was tricky because they didn't give us the total. Are you ready for a tricky one?
Yeah.
So pay attention to part and whole, or change and original, or something like that. Don't just throw the numbers in right away. That looks funny. Okay, I'm going to pause the recording again. If you're at home, try this yourself, and then we'll do it together. Okay, should we do right-hand side again first? That's what people like.
Yeah.
So start with there. Okay, before we jump in, let's just put the part and the whole and the percent like a label. So what was the part for this one?
$75.
Yes, it's asking for the increase. So the part or the change, that's the increase. It's the difference between them. We have to subtract. So 2 1/4 minus $1.50 gives us 75 cents. Okay, what's the whole amount or the original?
Would it be 150?
It is. Lots of people, if you are one of them, don't feel bad, have a tendency to pick the bigger number. It seems more like a whole because it's bigger. But when we're comparing what happens over time, the original amount is sometimes the smaller amount. Depends on if things are getting bigger or smaller. So we need to compare the change with what it used to be. Okay, and then finally, the percentage, that's what we're solving for. So if it helps you get yourself organized before you jump in to either of the fill in the blanks. Okay, now we could put them in. So this is the thing we're not sure what it is. I've been putting what, I suppose, on the blank here instead of y. The part is 75 cents. And the whole is 150. I'm going to keep putting a 0 in front, but you don't need to. That's just because I'm lecturing. Everyone okay with the setup?
Yeah.
So here. Can I put 1.5 instead of 1.50 and people don't mind? Or should I keep making it 1.50? No one has a preference. $100 times 0.75 divided by 1.5 gives me 50. 50% is just half. Does that make sense? Is 75% half of 150? You all got quiet. You were not quiet before.
I didn't get that right. I didn't do the 225 subtract 150.
Ah, okay. You want another chance with one similar?
Sure.
Oh, okay.
I use 225 instead of 150.
Let me think. Look through the list and find something similar. This is sort of like riding a bike. Once you've seen all the ways they're tricky, then you don't get tricked anymore. At a campus coffee cart, a medium coffee costs $1.65. Leslie brings $2 with her. She buys a cup of coffee and decides to generously leave all the rest as a tip. What percent tip was that? Again, I'll pause, you work on it, and then we'll check in. Okay, I will again make a list on the top. So we have our part, our whole, and that's as numbers. And then we have what the percent is, and we know the percent's whole, that's always 100.
I'll try it whenever we're ready.
Okay, go ahead.
Okay, so I did the translation method.
But first tell me the part and the whole and the percent, so I know what to plug in.
Oh yeah. Oh, I did the other one. Part and the whole. So the part would be 165.
Okay. The part is not quite. It doesn't ask for what percent is the coffee. It asks for what percent is the tip.
Okay, do you want me to do the other one then? Because that's the one that I did, is the translation method.
I wrote, you mean the proportion over on this side? I'm not sure what you're,
Well, I did 1.65 equals y times $2. I don't know if that's.
you're solving a different problem. You're solving the word problem. What percent of, did the coffee cost out of her $2? But it doesn't ask
Oh,
what percent is the coffee. It asks what percent is the tip.
okay. Well, never mind then.
That's okay. Common mistake. Good try.
I can try.
Okay, tell me what to rate.
So I don't know if I'm right either, but I got 0.35 for the change.
Okay, so however much her change was, that is 35 cents. So that's her tip. That's the change. Which is the whole, the 165 or the 2?
I did it as 165.
Yeah. When we're finding a tip, what matters is how much the food cost, not how much you had in your wallet. Okay, and the percent, that's what we're solving for. Okay, now I'll keep writing for you.
So I put y over 100. And then 0.35 over 165.
Oh, okay.
And then I cross multiplied.
Okay, then what?
Then you divide by 165 to both sides.
Okay,
So it'd be 35 divided by 165
okay.
and got about 21%.
Yeah. So she's a big tipper, but not gigantically. 20% is something that people actually do. If you're a translate person, then the part goes on the first spot and the whole goes on the last spot. Now, if you did it with the 160, with the, no, I'm gonna confuse people if I say that. Never mind. Okay, questions on any of this?
Not here.
If you need more practice, a great thing to do, whoops, why did all of those unfold? Is to go to the example problems and just try setting them up, even if you don't bother with the bottom part where you actually solve. And then look at the answer and see if you set them up right. Because as we've seen, figuring out what is the part do you subtract, or what is the whole, do you have to add things, right? That's where the problem writers try and trip you up. And that will certainly happen if you take a GED or something. They like making it slightly complicated. So practice a bunch, but perhaps just practice with the setup. Even if you don't finish, that's still a good thing to double check for yourself. And as always, at the end of every topic, you have lots of videos. And I wish you had a textbook to do even more, but you don't. But you have 10 problems here, and as many as you want. When the random, just reload the page and the numbers change. Okay, do you want to take a short break and then check back in and start working on homework? Do you want to have somebody do a presentation for something?
If someone's ready for a presentation, we can do that. But if not, I'm fine with doing the homework.
No one sent me an email saying that they're ready to do one for today, but I want to check in case somebody did, because it's neat to see what's interesting to you all. You want to break from so much arithmetic?
Yes, please.
Yes, okay, then I will do a presentation, but maybe we'll do a break first. So there's a playground with the Sonar and Spies game. So again, I click with the playgrounds, and then I go down, and the third thing is Sonar and Spies. So let's take a little 5-minute break, stretch our legs, warm up our beverages, whatever, and then we can play a game together and not have to move numbers about so much. Sound good?
Yeah.
Okay, I will see you all soon. Now for something completely different, we're going to do a game. This is sort of like the game of Battleship, but we are reviewing the little details of making coordinate graphs that you need for the GED in a way that's hopefully enough, but not too much, and kind of fun. So we're not studying all of these things about angles and stuff. That tends to be something you've either done at level B or seen elsewhere. If these things are brand new to you, let me know, and I can certainly teach them for the first time. But I'm assuming, unless you tell me otherwise, I'm just sort of jogging your memory. And we have a bunch of jargon that I will just explain real quick. So first, about angles. If I have an angle, then there's a point, and then there's kind of lines coming out in two directions, and how far apart that is how big the angle. A corner of a square is called a right angle. And angles could be smaller, or angles could be bigger, like the crocodile that's overextending and opening its mouth. So what was our fancy jargon for these? Which one is which?
A right angle is 90.
Yeah, the right angle is 90. We don't actually care about the number 90 now, but if you know that, great. It's just the corner of a square, like straight up and down or sideways, or it used to be that, but we spun it around a little bit. What's the smaller one named?
Is it a cube?
It is. And then the other one is called obtuse. So just jargon to remember. Lines that are parallel are like railroad tracks. No matter how far you go, they will never cross. Lines that are perpendicular are like a plus sign that they make right angles. There are other lines that aren't either of those. They kind of cross a little bit, but not like a square. And those don't have a fancy name, but parallel, perpendicular. Our class has already talked about the 4 basic polygons, perpendicular, the rectangle, triangle, parallelogram, and trapezoid. There's also a square, but squares are just special cases of rectangles. Okay, these things are the axes. If it's plural, it's AXES, but that looks too much like the word axes, like chopping down tree with axes. But axes is plural for axis. And one goes up and one goes down and they cross 0. And usually we don't try and label the 0 just because it gets a little crowded to put zeros in for both number lines. There are 4 quadrants. So this section, oops, this is one of the quadrants. This is another quadrant. This is another quadrant, and that's another quadrant. So it's just sort of which corner you are in your 4 axes. If I want the point 2, 3, that always means go over 2, 1, 2, and then go up 3, 1, 2, 3. So this point right here is 2, 3. And the way, let me do that in a different color, it will stand out better. And the way to remember which is that we are not Superman. Superman might be able to go to the top of a skyscraper by going up first and then over. But we can't fly, we can't do that. If we want to get to the top of our skyscraper, then we have to go over first, the 2, the first number is the over, and then up with the second number. And then lastly, the fancy name for the counting numbers, 1, 2, 3, 4, no decimals, no fractions allowed, but negatives are okay. That's called the integers. Questions about the jargon?
No.
So how the game works is there's 2 teams, and I've given everyone right on the Jamboard privileges. You might need to reload the Jamboard. And if you need the link, I will put it in chat so you don't have to open up your math website and go to the top and click on it. So go to page 11 or 12, and we'll make 2 teams happen. And one team could be on this Jamboard, the other on the next one. So you're going to make the 4 basic polygons. Maybe you want to have a rectangle and a triangle and a parallelogram and a trapezoid. So you have to have all 4 of the basic polygons, and you have to put their corners on the points. My art wasn't great, but you're not allowed to kind of hide the thing and have the corners be, oops, like floating in space. Does that make sense? You have to have integers for all of your corners. You have to have at least two sides that are horizontal, straight sideways, or vertical, straight up. So you're not allowed to make a funky triangle like that, where none of the sides are horizontal or vertical. And all of your shapes must have an area of at least 6. Some of the ones I made are needlessly big, but you're not allowed to try and make like a little bitty square or a little bitty triangle to hide it from the other team. They have to have an area at least 6. And finally, on your game board, one of the quadrants will be empty. One of them will have 2 of your shapes, and then the other ones left over get 1 shape each. Everyone okay about my setup rules?
Yeah.
I should put the goal. So the goal of this isn't to be like Battleship. If you're playing the actual game of Battleship with your kids, it's kind of annoying and slow because you have to hit every spot on their ships to sink them. We are not going to do that. Our goal is much simpler. We are only trying to find which polygons are in which quadrants. So as soon as you can tell us, I know where all of the other teams' polygons are, their square is in the top left, their triangle and parallelogram is top right, and their trapezoid is bottom right, then you win. How do you find out which shapes are where? Well, you have to use your spies or your sonar. So when you take your turn, you'll just do one thing, but you have 3 choices. And if you're playing this at home with your family or kids, you can do this with more than 2 teams, but we're just going to be 2 teams to be easy. So you can do a sonar sweep. You're going to pick a point on either axis. Let's pick 6 on the up and down axis. And then you look along this line, and the other team has to tell you, are there any corners on that axis? It's just a yes or no question. They would say, yes, at least one of my shapes has at least 1 corner on that line you drew. Or they would say, no, your sonar sweep missed. Notice that this goes right through the middle of shapes. If you were to pick, let's do 4 and go up and down from 4, then you happen to go through 3 shapes, but they will say, nope, you didn't hit any corners. Is that okay for sonar sweeps?
Yeah.
So that's hunting for corners. You go straight up or straight down or sideways. You can try to contact one of your spies. So you're going to send a spy to somewhere on the board, maybe 4,3, right? Over 4, up 3. And then the other player will tell you, are you in one of my shapes, including the corners? And they would, so this part, they would say, yes, you're in one of my shapes. And then lastly, you can get a report from one of your spies. It's a yes or no thing, and it's a fill in the blank where you ask about one of the quadrants. So does the northwest quadrant or does the top right quadrant have any of these things or have none of these things? And then you pick one of the jargons that we just talked about: acute angles, right angles, obtuse angles, parallel lines, and perpendicular lines. If you find where they have some right angles, then that means you know where their rectangle or their triangle is. If you find where they have some obtuse angles, then not all of these shapes have obtuse angles. Which ones could have obtuse angles?
Parallelogram?
Right, 2 of the parallelogram angles are big. And then the trapezoid will have 2 also that are big. It's not just a straight down thing, right? It's open wider than that. Which shapes have parallel lines?
Rectangles.
The
and
rectangle does.
Parallelogram.
Square.
And the trapezoid does too. The base and the top are parallel. So if you find out which corner, which quadrant has parallel lines, that helps you know what shapes are there. Which shapes have perpendicular lines?
None.
That's the same as the right angles. So
Rectangle.
rectangles do. And just because we're requiring you to make sides horizontal or vertical, then these triangles will. It's easy enough to draw a triangle that doesn't have any perpendicular lines, but we're not allowing you to do that in the game. So I'm going to stop sharing my screen because I don't want everyone to look at each other's stuff, right? So figure out who's on what team. Some of you look at page 11, some of you look at page 12. I'm going to erase all the stuff I've drawn. And then, oops, is that the goal? There we go. And then once you have your teammates, pick where your shapes are, try and make them so that they are at least 6 square units of size, but not too much larger because you don't want to make it easy for your shapes to be found. But it also might confuse your opponent if they're looking for smaller shapes and you have a great big one. And then we can take turns doing one of these 3 things and see if you could figure out which shapes they have in which corners, in which quadrants. Any questions?
Do you just pick what slide you want to be on?
Sure, I'm going to stop the recording for now at least.